they had these old computer screens that were black. So I'm going to simulate that here. I'm going to add a sheet to my paper. Where'd it go? That's not my sheet right here. And you don't have to do this. You can just follow along if you want. But I'm just trying to set up our problem for today. Back in the day, it was like a black screen. So just imagine this black screen. And on the screen, the text would be kind of a greenish, kind of a light greenish. Let me zoom in a little bit. Yeah. And this is what screens in the 70s looked like from the computers was black screen, green text. Um, it, those were the days. Actually, it's probably a little bit lighter green now I think about it. There was no mouse. Um, in fact, just to go way back, we could use the Courier font. There we go. This is like almost the text that you would see like in Terminator 2 or something like that. Later 70s or where? I was all keyboard. Tab, 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 or shortcut key. Yeah, it's pretty amazing. Um, but to kind of set up the problem for today that we're going to do in VBA is back in the day, it was very expensive to go to the network, like I'm talking about computer network, and to search for information on the network. It was also very expensive to write to disk, right? In fact, it's interesting. One of the things that used to cost $1 million in 1970s, that costs 2 cents today, is 1 gigabyte of space. It used to cost $1 million. I mean, that was only 50 years ago. Cost $1 million, now it costs 2 cents for a single gigabyte of space. And so back in the days, you would write programs, but you would avoid going on the network because again, it was expensive both in terms of time and money, or writing to disk. Writing anything to disk was just expensive. And so one of the things they did when they came up with this during this time was, if you go to the banks, one of the things that a simple transaction at the bank, you would have like an account number, right? If you went to deposit information in a bank, you would have your account number and you'd have an amount that you would deposit, right? And let's change this to this guy. Change the text to black on this one. Kind of the reverse of this is the two options, right? You only had two colors back then, black and green. One of the challenges was about the account number. How do we validate the account number? So let's say the account number was, I don't know, 256 82. Let's say that this was the 25,682nd account at this bank. And let's say that we just wanted to put in an amount. One of the things they came up with was, how do we validate this account number? We don't want to write to disk. We don't want to write to the network to see if it's valid. And so one of the things that they did is they say, hey, let's do a checksum. And they would calculate what the sum is of this account number. But they would do the digits, right? What's the sum of the digits? 2 plus 5 is 7, plus 6 is 13, plus 8 is 20. I do that right? 7 plus 6 plus 8. Yeah, 22. Total is 23. So what they would do is they would take the account number and then they would add the last two digits of this account number were actually this check sum of the previous 5 digits. And the idea was they could check very quickly without writing to disk or without checking on the network if this was a valid account number, right? You add the first 5 digits together. If they sum up equal to the last 2 digits, then you know it's a valid account number. In fact, they do this sometimes on websites. You ever typed in your credit card incorrectly when you're buying something and it immediately comes back and says, no, it's wrong? Maybe you don't have that. Maybe you've never done that. But often there's a checksum or algorithm that's run on your credit card, very similar to this, but different, where they say, let's check the numbers to see if it's a valid card, a valid number. And so they did this for a while. There was something else that came up, and they said, instead of making it the last 2 digits, what if we just had the last digit be the checksum number? And what if instead of just adding up the digits, what if we multiplied the first digit times 1? What if we multiplied the second digit times 2? What if we multiplied the third digit times 3, et cetera, et cetera, et cetera? So these algorithms for checksums became much more complex. And today what we're going to do is we're going to run through this complexity of checksums for an ISBN number, okay? So if we go to the ISBN link here, I think if we go back here, there's an ISBN page at Wikipedia link. And it turns out that there is a check digit calculation for an ISBN 10. And this is the calculation that it goes through. In other words, the first 9 digits of an ISBN number are the actual number. The 10th digit of the ISBN number is like a checksum. It checks to see if the other 9 digits are valid, that those 9 digits are a valid number. Pretty cool. And so here's the graphic. If we go back to the spreadsheet, if we go to sheet 1 on this spreadsheet, in fact, let me close that. That's being a little bit confusing. Sheet 1 is the graphical representation of this ISBN checksum number. It's going to take the first digit and multiply that by 10. It's going to take the second digit, multiply that by 9. It's going to take the third digit, multiply it by 8. That's 24. It's going to take the fourth digit, multiply it by 7. The fifth digit by 6. The sixth digit by 5. The seventh digit by 4. The eighth digit by 3. The ninth digit by 2. And then it's going to sum all that up. So we have 236, but that's not the end of it, right? So after we sum this up, it says there's more that we have to do. It takes the sum of that number, 236, and it says mod 11. Basically, that's like a remainder. So if you divide 11 into 236, what is the remainder? What's the remainder that you're left over with? So 236 mod 11 is equal to 5. You take that 5 and you subtract it from 11, that gives you a number. You take that number and say, what's the remainder if you divide by 11? And that's the check digit number, is that 6. How about that? That's the check digit number for the, so those steps are the steps that you go through to validate if this is a valid ISBN number or not. And if this last digit, if that 6 is the same as what you put into that ISBN number, then you know it's a valid, it's a well-formed ISBN number. And by the way, there is a situation sometimes when you get to this step and the leftover is 10, right? Because if you're dividing by 11, it could be anywhere from 10 to 1. If there's 10 left over, that's where the X comes from. Then they actually put in a Roman numeral X in that last position, which is kind of interesting. So if you ever see a ISBN 10 with an X in the last position, that's because this last number is a remainder of 10. And they use the Roman numeral because they only have one digit there. So, by the way, this is the project. For the project, you're going to be doing an ISBN 13 due next week, a week from today. So very similar to what we're doing here today in ISBN 10, except it's going to be 3 more digits. And some of the steps are a little bit different, right? But very similar steps that we're going to go through in our code today is the kind of code you're going to work on for the project due next Wednesday. And I think that's the next assignment due. I don't think there's any other assignments between now and Wednesday. Oh, delete a worksheet. Is that due Wednesday as well? Or is that due Monday? Oh, that's a good question. We're not meeting Monday. We're meeting Tuesday and Wednesday next week. It's due Tuesday? Okay, great. Yeah, we'll cover that. We'll cover some more questions on that on Tuesday. Okay, great. So let's go ahead and open up our code here. And the goal, again, is to identify when we submit an ISBN number, is this a well-formed, is this an accurate ISBN number? So if I go to the code here, there's no module. So I'll go ahead and insert module, and that'll give us our module. And we're going to do a function, right? There's 2 kinds of procedures. That reminded me I'm halfway through writing the midterm. The midterm's halfway done, just so you know, FYI. And there is a question about these 2 different kinds of procedures. What are the 2 different kinds of procedures? One is a sub procedure. Yeah, we've done that a bunch of times. The other one is a function procedure, right? We've just started talking about that. And we're going to write a function procedure here because we want it to return a value. So we're going to call this function. We want it to return to us whether or not this is a valid ISBN number or no, this is not a viable ISBN number. So true or false. That's kind of where we're going to go. So let's write a function here. This is going to be a procedure, a function procedure. Let's call this is valid ISBN 10. And we have an input to this. And let's say it's a candidate. This is the candidate number. We're going to write this as a string. Why does it have to be a string? Mostly because we might have an X in it, right? So, and some other string. We could have dashes in it. So I think it's better to have a string as the input. And then what's our output? Our output is going to be a Boolean. We want to know true or false if this is a valid ISBN, true or false. And then how do we return the value? In our function, we have to call the function name again, is valid ISBN 10. The exact name as it is up here. I could just copy and paste it just to be sure. And we're going to set that equal to, it's expecting a true or false. The default value for a Boolean data type is false. So I'm going to go ahead and set this to true for now. We're going to come back and put a whole bunch of logic in here to test. But we can actually test this right now. This is in our code. This is a valid function syntactically. We can come to our spreadsheet over here. And if I type in ISV, there's the function that we just wrote right there. So if I type in this function in Excel, if I reference this cell, it says, yes, this is a valid ISBN. Now, is it actually doing these calculations yet? No, it's not. I'm just telling it to return true no matter what you put into it, right? That's all we've done so far. So it's always going to be true. But once we put in some more logic into this function, we're going to have it. We can use that in our Excel, which is pretty cool. Okay. So let's write some code. Here we go. We're going to need a loop. We're going to need checksum. Let's do a couple of variables here. Let's create a dim ISBN as string. Let's do a dim checksum as, let's see now, checksum. That's going to be the number that we're going to check at the very end, right? Is this a valid ISBN? Integer is probably going to work. We're going to have to do some calculations. I don't think we'll get something larger than 32,000. If we have 9 characters, 9 times 10 at the most is what, 90? So let's go ahead and use integer. It's big enough. I don't have to worry about it. Small enough. It doesn't take up a whole lot of room. Oh,
Just put in a safety like larger, they're called, but instead of like.
like a single or a double or a. Not necessarily. I wouldn't put variant because sometimes variant thinks it knows what it does and tries to make it right, and it often doesn't. But if I put in here double or single, it would still work. The benefit of not doing that is just understanding where your data types are, so that if you have a larger VBA program, it doesn't slow it down, right? Like if you're resetting this, if I was resetting the checksum and it was like a double and we were talking huge numbers, then it could start to affect the performance of your code.
When you say we're going to use integer instead of whatever else to not take up so much space.
Yeah.
What do you mean take up a lot of space? Like where is that space being taken up?
On your RAM, on your memory. Because when the code runs through this, VBA in Excel is going to go to the operating system and say, hey, give me some memory. And based on whatever this data type is, it knows how much to memory to ask for from the operating system. And so it's going to go find a location in memory, reserve that location, send that location address back to your program here, and that like takes up that memory. I mean, it's like it's spoken for, right? So you kind of want to be pretty cognizant about how much memory you need as you run the program, as you write the program. Yeah, good question. Okay, we've got that. Let's also do an X here. Let's dim an X because we'll do that for our loop. What we'll do the loop for is we'll go through each character in the ISBN that's submitted, in the candidate, right? Here's the candidate that's submitted. We're going to go through each one. And so this will be kind of our counter for our loop as we do that. The first thing we can do is let's get rid of all the characters that are not numeric. So if I submit a character like the ISBN from the Wikipedia, like this guy, I want to just be able to come in here to the code and then submit something like that, right? So if I were to type in is valid ISBN 10, ISBN 10, and I put in this candidate string, I want it to be able to take out all of the non-numeric characters. Let's do what, 2? And again, if I run this, it still says true because down here, I'm still sending it true no matter what we do here. So this true doesn't really mean anything yet. But let's do this. Let's write another function. And let's say, in this case, ISBN is equal to valid characters function. And we'll pass the candidate to this new function. So I'm going to come down here and I'm going to create a new function down here. And the function name is going to be valid characters. So we started one function. It's going to pass information to a new function, in this case, valid characters. Let's take in some data. This is going to be what's passed to it. And then we're going to return another string back out of it. So we're just going to use this function to take out anything that's not numeric. And we should probably also include the X as well. So we'll do special instructions for the X there. Okay, so we've written the first, so just real quick recap. We've written the outline of this first function here. We're going to pass the candidate into this second function, valid characters, and we're creating that second function down here. We're passing the data as a string. That's going to be this candidate. It's going to be data in this function. We're going to return the string, but without all the other non-numeric or X characters. Okay, so in this one, let's do some of the same things. Let's dim X as integer. Let's dim temp as a string. This will kind of be the return value that we send it back. And we've done this before in another function. Let's dim one char as a string as well. And let's create a loop. We've done loops before. For x is equal to 1, 2, length of the data. So we're going to write a loop. We're going to go through each character. And let's identify each character. So one char is equal to, let's do mid. And we have this data, we have this ISBN. Let's take out one character, but let's start whichever x is in the loop. So x is 1 here, we're going to start at the first character. And we're just going to take one character out. So mid is saying, given this string, start at this character, whatever x is, give me that length, one character length, set that equal to one char. Okay, so we're just looking at one loop, one char. And then we need to test if this one char is numeric, then do something, right? That's basically what we need to figure out. That's what we need to test for. If it's numeric, then let's add it to the temp and it's valid. If it's not numeric, we'll just ignore it. Sorry, dear. Let me scroll up a little bit. Sorry. Let me pull this up here. Is that a little bit better? Got to put some more spaces down there. Yeah, sorry about that. But this isn't exactly new. This isn't exact syntax. What we're going to use is, it's called an is numeric function. So if is numeric one char, if that's true, then do something. What are we going to do? We're going to add it to this temp variable. Temp is equal to temp and one char. How about that? Okay, so let's try that. So I'll come up here. I'll say valid characters. I'll call this ISBN from the wiki. And this should return blank. It returns blank. Why does it return blank? Should we stop it? If I stop it here, I can go back in here and check what is my temp. There it is. There's my temp. Yeah, there's one more thing I'm missing here. I forgot to send back the value, right? In order to return the value, what do I have to do? That didn't help. Okay, no worries. I'll just type it in. I actually have to call the name of the function inside the function. And I have to say, okay, valid characters is equal to temp. Does that make sense? So I've created this temp here. And in order to return that value, I take what I created from inside this loop and I say valid characters, which is the name of the function, equals temp. And then it knows to return that value at the very end of the function. So I'll take out my stop. I'll add this valid characters equals temp. I'll run it and then it will print it at the top. So one more time here, if I do valid characters and I give it what was that ISBN again? It's going to return just the numbers. It's going to kick out all of the dashes in this point. If I say X, X is not included. Okay, is that going to be a problem? Yeah, that's going to be a problem. Because we could submit an valid ISBN that has an X. So let's account for that. Let's do that right here. If the number is numeric, or, let's do an or here, or one char is equal to X, then we'll add it. How about that? And just to make sure that we don't get messed up with the upper lowercase, let's add one additional function that says L case at the front of this. L case open parentheses, one char, and then close parentheses. And let's add the lowercase down here as well to our temp, just so that we don't get any confusion over if it's uppercase or lowercase. So we have a lowercase function. We're taking that lowercase of one char. If that's equal to X, then we're going to include it. So now if I run this again, there's the X. So it's included into our temp because we added this or statement here. In addition to this is numeric function. Okay, let's do a little partner check. Partner, this is where I'm at. Tell your partner where you're at. If you have no partners, what do?
Class out, I can leave.
You can go. Your partners are done, so you're done. Garrett. Okay. Are you close?
Sort of. So.
Smart. Look at you.
Yeah,
Makes a difference, right?
it's so much difference.
I'm glad to hear that.
So like when I put this in, it just gives.
Subber function not defined. Valid characters. Valid character. Let's see. Is that the same thing?
I think so.
And you have an in function on that one? Okay, great. Valid characters dash is string. Function valid characters equals temp. And that's the temp you're creating right there. If is numeric, lowercase, one char, dim. Oh, interesting. Let's go up. Do you have another? Is this one function? Is valid ISBN. Okay, you have a 10 there. I don't think that would have changed. Yeah, you can take those out. Yeah. Yeah, see if that was it. No, subber function not defined. It is defined, right? Valid characters. Oh, you have to have it. You have to be this in a module.
Why not?
No, so right now you're in this workbook. So you have to go up to insert module and then copy and paste this code into a module. So it's looking for it. It couldn't find it. You had the right code, just not in the right place.
Go do it says sub or function not.
That's what he had.
I am in a module.
Oh, you are not. Phew. Phew. This one has an S.
Don't they all have an S?
Well, not this one up there. Yeah, your code's probably right. Check that. See if that works. Oh, good.
Enter.
Expected line number label of statement or in a statement. Where was the plus?
Just up here. I added that one to so I can get the same kind of similar.
Yeah, if you go back one more, I don't think you can do a plus there.
Can we run it?
Yeah, you just have to go backward space one more time on your backspace, and then hit enter. So you just have to enter on that line. Does that work?
Okay.
Yeah.
Main.
Subber function not defined. Oh yeah, I think this one's spelled differently than that. So you just have to spell them the same.
Oh.
However you want to spell it. It doesn't even have to be correct spelling. You know what I mean? It just has to be the same. How we doing? Good? Okay, great. Question? Sure. Inside outside procedure. Never seen that one before. You're so cool. What did you run? Valid characters?
Yeah, but it's highlighting that. And I'm in a mod role. It's
ISBN2 option. Is there a space between option and explicit? I think there's a space between those two words. That might be it. You probably just confused it. It was like, I don't know what you mean.
that's it.
Integer.
And
I read it again, yeah. There it is. Bingo. Got it. Nailed it. Okay, great. Okay, so at this point, we have created our first function, is valid ISBN 10. We created a second function to send it to. Now we took out or we stripped out all the invalid characters. We could do a couple of tests, right? We could test it and say, let's come in here, put a dot, maybe put in a backslash or something, a space, and we should still get a return of just the valid characters. Okay, good. Momo Biso, how's it coming? What? Is it spelled the same? And it's in a module? I'll come over there. It's easier to correct it sooner than later. Did it work?
yeah.
Valid characters is string. Valid characters. Data is string. Yeah, hit play. Or hit enter. Yeah, go up here and hit enter again. Variable not defined. Oh, I think you just need dim x as.
What? Team X, Team X, that's interesting. Team
Yeah, so instead of ISBN, change the ISBN to X.
ISBN.
Yeah, dim ISBN, change that one to X.
X.
Yep. And then hit play. Or that, either way works. Wait, did you just, careful, do you know what you just did?
No.
You just erased all your code.
Oh, really?
Yeah, click on save again. Well, that won't do now, but you have to save it as a different file because right now it's XLSX. So if you were to close this, all of this would be gone. So do file save as. In fact, you may have to do that. Go to file.
File.
Yeah. Yeah, you might have to do it on the Excel. Go to your Excel file real fast just so we don't lose anything. And do file save as.
A file.
That's right. File save as. And then browse. Where do you want to save it to? And then instead of a workbook, click on that and save it as an macro enabled workbook. And that will save your file. That'll save your code.
Yeah.
Okay, go back to the code. Let's run it one more time. Yeah, click enter. Okay, good. So we have a for loop, but you need a next. So after the indef, type in next. Next. And run that, see if that works. You got it. Hey. Yeah, hit reset. Still highlighted. Yeah, just hit reset. No. The other one? Oh, the other class. Yeah. No, I think this one's gonna be on, it's gonna be online. That's what we decided, right? Online, not the testing center, not Proctorio. I'm pretty sure it was not open book. Pretty sure. I don't think it was. I don't think it was. Really? All right, we'll have to talk about that. I don't think. Okay, great. Now what should we do? So we've got this part. What we need to do is put in the logic here. So let's create some logic. Now we have the digits. Let's put in some logic. So at this point, we're back to our main function. Again, we've used this valid characters to say, give me just the numbers or the X. And now we can do the logic on this, right? So let's start to create a checksum. So if I go back to this, we're going to try to go through these steps for this ISBN. Now that we have the numbers, so let's try this. Let's do checksum because we created the checksum variable up here. Checksum is equal to, we'll take the first one, left. We're using this ISBN variable now. That's where our data is at, ISBN. And we're just going to do 1. Left 1 of ISBN. We're going to multiply that by 10. Because that's the rule here that we're following for our checksum. Take that first digit, multiply it by 10. Then what we can do is checksum is equal to, let's take the second digit. So that would be mid ISBN. Start at, what are we going to start at? 2. And we're going to take one digit and we're going to multiply that by 9. And then we're going to add it to the checksum, right, that we did before. Because that's what we're trying to do, is we're trying to add the checksums together. Let's do another checksum. Let's take the mid ISBN. This will be the third digit. So we'll do 3, 1. Multiply that by 1, 2, 3, 8. And we're going to add it to the checksum. And let's do another one, checksum, mid ISBN, the fourth digit times 7 plus checksum. Now we should start to see a pattern here, right? If we're writing code and we start to see a pattern like this, where we're using the same functions, but our numbers are changing, these are going 2, 3, 4, these are going 9, 8, 7. We could make this into a loop, right? We shouldn't necessarily be, that's what we should think. We could keep going like this until we do all the digits, but there's a better way, right? So let's write that better way. And let's do a for loop. Let's do for x is equal to 1 to 9, because we're just looking at the first 9 variables. Do a next. So here's how I'll start my loop. I know I need to do this 9 times. And I know I need to figure out what the checksum is. So I'll say checksum is equal to, in fact, if I look up here, this one right here could also be a mid. I could use the mid here, 1, 1. And so that's exactly the same pattern over and over and over, right? What would this pattern be in the loop? It would be mid ISBN, comma. Okay, now what do we do here? Where do we start our mid? X. Who said that? That's right. We can use X as our starting point because that's the number in our loop, right? So we can do ISBN, comma X. Mid extracts text from a larger string. It's like, hey, give me something inside of this string. So mid is saying, here's a string, give me something just inside of it, like a mid. There's a right and a left and a mid. Yeah. So we're saying, give me the mid, and we just want one character. So this would be X, comma 1, because everything we're going to extract, we just want that one character. Now, here's the hard part here, this multiplication. So if X is 1, how do we get it to be 10, right? We want a 10 here for the first time. We want it 9 the next time, 8, etc. If X is 1, how do we get this to be 10? 11 minus 1. That would do it. And then instead of 1, we could use X. Yeah. How about that? How about that? So if we do 11 minus X, Now let's test this, right? The second time through, if X is 2, we're gonna do mid, the second digit, let's say the second digit is 3. So if this is, if the second digit is 3, that's what this is gonna be. This is gonna be 3. 3 times 11 minus 3, which is gonna be 8. Is that the right one? That's the third character, and we're doing 8. So I think that works, right? 11 minus X is gonna give us the correct value given this loop. So I think that's right. And then finally, we just have to add the previous checksum, right? How about that? So we've just created a loop for our checksum instead of writing out each line, just like that. That's pretty cool. That is pretty cool. If I wanted to comment this out, let's see, which one is it? Edit. Where's that one that comments? There's a place where I can comment out multiple lines. Toolbars? Yeah, here it is. There's an edit toolbar. So you can just comment these out individually, or you can go to the edit toolbar and it allows you to comment out the block all at once. It's just a quick way to do that. Sure, go to view toolbars and then the edit one. And if you select the edit toolbar, there's an option right here next to the hand to comment the block. And I could uncomment it right next to it, uncomment the block or comment the block, all those lines. So I just wanted to get rid of that. I mean, I could delete it too, just in case anybody wants to see that. There's a pattern there, and when you see a pattern, more than likely there's a loop that does the same pattern better. I like the loops because not just because it's less typing, but because there's less chance of error, right? If I'm typing this line over and over and over again, there's more room for error than if I just do a loop. Okay, there's another check we can do. In fact, even before the loop, we can check for, if I come back up before the loop, let's check to see if the length of this ISBN is not equal to 10, then we're done, right? So if we pass it a function and there's less than 10 actual characters plus X, right? Let's say that we pass it this function, which has less than 10, we can just exit the function. It's like, no, we're done. When we exit the function, the default value for Boolean is going to be returned false. So for example, we can do that over here. Let's see if this works. Is valid ISBN. Let's do 1, 2, 3, 4, 5. And that's going to be false. So it recognizes that because there's only 5 digits here, it says the length of this ISBN is not equal to 10. That's what this not equals is for. Not equals to 10, then exit the function. We're done. It's out. And in that case, the Boolean defaults to false. And it doesn't even read everything else. It doesn't even get to this part. It just exits the function. So there's our first check. The first check is it 10 characters? If it isn't, then it's going to exit the function. If it is, then it goes through the loop and it says for the first 9 characters, get your checksum. So now what we know, now that we know the checksum, we can check to see if that's the correct checksum. But there's some more calculations. So all we've done so far is we have this sum right here. We know what this sum is. At this point, we have to do checksum mod 11 to figure out what that is. So let's come down here and I'll do checksum equals checksum mod 11. And that's going to say, what's the remainder? If we divide this checksum by 11, what's the remainder? That's what the mod is, please.
Maybe I should have asked this. Why do you I understand finding the remainder, but
Why do they find the remainder?
why-
Yeah, good question. Because there's 10 digits less than 11, right?
okay, so you put whatever number there plus 1. whatever number.
Say that one more time.
For the project, isn't it 13?
So
Yes. Depends on the rules. So this particular rule set for identifying the check digit says find the remainder after dividing by 11. So if you were to go back to do ISBN 13, for example, I think that's over here. ISBN 13 check digit calculation. There's a little bit different rules here, right? Here's one mod 10. So this is saying divide by 10, give me whatever the remainder is. That's what I want. So this one was mod 11 up here in check 10. Here's mod 11. That was just the rule that they made when they created this. And when they created ISBN 13 check digit calculation, they said, give me mod 10. Does that make sense? Right. You're going to follow the 13 rules, which are a little bit different than 10, than the ISBN 10. Yeah. Does that answer your question?
Well, yeah, the last sentence you said. Maybe the rules wide.
Oh, yeah.
The ISB 10 rules, you got a lot of them.
Yeah, it's something. So for example, I mean, I don't know the answer to that question. Right, right.
Yeah.
Use sum to modulo mod 10 to give a value ranging from 0 to 9. So one of the reasons why they do mod 10 is because the outcome of that has to be single digit 0 to 9.
So the le- uh, 11 digit ISBN can have an X with the 13. cannot have an X.
Yes, a 0 replaces a 10. So even if there is something that has a 10 in it, a 0 replaces that. Yeah, that's right. So there's no X in 13. Yeah, that's a good point. Okay, great. Good questions. Does that help? A little bit? I mean, it does make you wonder. I'm with you, Spencer. It makes you wonder who came up with it. Wouldn't that be an interesting career? Is to go figure out what's the best rules to calculate the check digit for ISBN codes. I mean, that's kind of an interesting question, right? Who came up with that? Yeah, that's a great question. It wouldn't? That wouldn't get you out of bed? What gets you out of bed, Spencer?
Just found out yesterday.
Whoa, stop. What's your first one? That's pretty cool. That's exciting. How's your wife doing?
Fine. Doesn't got morning sickness. Won't eat eggs, but she'll eat eggs.
Oh, wow. Eggs are nasty. Sulfur. Wow. That's exciting. Congratulations. What about names? Okay, sorry. We can talk about that another time. That's exciting. Congratulations. That's good to hear. That's great. Okay, so at this point, we've done the checksum. We know what the checksum is for the first 9 digits. There's a couple more rules here that we're going to follow. We're going to take what's the remainder. So mod is like, give me the remainder when you divide by 11. After that, what's the next step? We're going to take that number and we're going to say 11 minus the checksum. So the new checksum is going to be 11 minus the checksum. Once we do that, we do another version of the checksum. Here's that 6 right here. Comes over here. 6 mod 11 again. So we're actually going to do checksum equals checksum mod 11 again. I mean, kind of seems odd, right? But that will give us this final number here. And that's the number that we can check. There's one more last step. What if this number is 10? We have to make one more account for that. So let's do one more if statement. If checksum is equal to 10, and let's take the rightmost character, ISBN 1, the farthest right digit of ISBN, if that is equal to X, then do something. What are we going to do? Then we're going to say if the checksum is 10 and if the rightmost character is X, then that's correct, right? Then we're done. We can say is valid ISBN 10 equals true. Then we know it's true. So there's our first logic. We did it. Sorry, let me rose this up. You bet. Here's our 3 checksums after the loop. Here is we're checking for if this checksum, now that we've done all the calculations, we're done with the calculations. If the final checksum is 10 and the rightmost character, single rightmost character is X, and we know it's going to be lowercase y. That's right, because we did the lowercase down here. So we know we already put it through this function. It's going to come back lowercase. So if it's a lowercase x and the checksum is 10, then we know we're done. We're done with the function is valid ISBN is equal to true. Let's do an else if. Else if the checksum is equal to the right ISBN digit 1, what do we do then? Why false? We're saying if this checksum here, right? If this checksum here is equal to the last digit in the ISBN that we submitted. So if it's the same, then it's true. Then it's valid. That's exactly what we're looking for, right? If that checksum is equal to the right digit, we only did this up here because of that one specific special case where the checksum is 10. So we did that first, right? That was the first thing we checked in our if statement. We checked, and in fact, that's an interesting way to do your if statements, right? If you check for the most rare case first, then you can do an else if for all the other cases, right? I mean, you could do it the other way too, right? You can check that else if, but checking for the special case first it's a better flow. It's a much better flow. So we're checking here for that special case. If the checksum is 10 and the right character is X, then we know it's a valid ISBN. Else if the checksum number after this final calculation is equal to the rightmost number in the ISBN that was submitted, then we know this is true as well. So that would be true. And then we could do else. Else, if it's not either one of those, guess what we're going to do? We're going to set that to false. And those are basically our three branches of logic here. And then we have to end our if. Don't forget your end, your if. Can you think of any case where, and we can take this out, right? We don't need this anymore because we've already included the logic up here in this if statement. So we can take this out. That was just kind of a placeholder while we built the rest of our code. Else if this is equal, then that's true. Else, it's not a valid ISBN. There's one situation where there's a little bit of difficulty here, and that is, let's see, should we address that? Let's start testing this. Let's test this to see if we got this right. So I'm going to come back up here. I'm going to say is valid ISBN 10, and let's type in, where did this guy go? 13, or no, it's my 10 digit. Here it is right here. I'm going to include the 2, so I know this is valid. In fact, I'm curious, what book is this? Does anybody know what book this is? Oh, wow. It's like an error correction coding book for digital communications. Huh, that's pretty cool. If I use this ISBN number in my code, if I call it here, it should return true, right? That's what we'd expect. It's going to clean out all the non-numeric characters with this function. It's going to come back up here, do all the calculations. It's going to check to see if this is a valid ISBN. It should say true or false. I'm expecting this to be true, and it's true. Okay, so far so good. Is there an ISBN that we can come up with that has an X to see if the X is allowed? Does anybody have an list of ISBN numbers we could use? Harry Potter book ISBN numbers. Oh, look at this. Isn't that great? Okay, here's one right here. Harry Potter and the Goblet of Fire. This is one where it has X at the very end. This is 10, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. So if I come back to the code and put in that ISBN, this should be true, right? If we did our calculations correct, and it is, how about that? We could also do this. Let me come here and just, I could copy and paste this into Excel, and we can actually run it in Excel, right? So let me come down here, paste it, zoom in a little bit. We can do a data to text, text to columns. Let's delimit it by, how about an other, and we'll do a space hyphen space, or is it just one? We'll do that. We'll finish. Gave me all this weird stuff. Oh, interesting. There was a hyphen in the name. That's kind of cool. Half-Blood Prince. And then let me move this over here. Okay, so here are our ISBN numbers for Harry Potter. I could come over here and say, is valid ISBN, and reference each of these. Whoa, that's false. What happened? Only one of them is true? Oh, what is it missing? It's missing a 0 at the front. Look at that. It took off my 0. I pasted it into Excel, and Excel's like, oh, that's definitely a number. And it wasn't a number. So I'm going to change these all to strings, and now they work. I didn't have to change that one. That one, that one kept the 0 in front because of the X in the end. Not bad. Okay, let's do a couple more checks here. Is there another way we can check this? What if, okay, here's a curious one. What if we take this number, and what if we use this number down here? And what if we put the X, what if somebody accidentally put the X here on the inside instead of the end, right? What would happen then? Yeah, that's going to be an error, right? It says, wait, I don't know what to do with that inside X. It's possible that they could do that. One way we could fix that is we could add this to the code. Let's add this. Let's go back to our code. And inside of the second function, when we are going through the function for the second time, when we're checking to see if the character is numeric or if it's X, one thing we can do is we can change that and say, we can add an else if. If the character is X, let's see. if if the character is numeric or if it's lowercase x, then add it. Well, maybe I won't do that today. Maybe I'll wait for that another day. Yeah. In fact, maybe I'll let you guys figure that out. Can you figure that out? Can you check to see how would you handle an additional X in the inside of an ISBN? I think that might be helpful for the project too. And then how would you handle that in the code, right? It should come out to be false. Instead of just an error. So why don't you do that? Why don't you take 5 seconds or 5 minutes to do that? See if you can work with somebody else. What would that look like? If you had an X in the code, how do you get that to say false right there? On the inside, if the X is anywhere except for the last position, how would you do that? And then let me come around, see if you guys have any questions, comments. Questions, comments? Yeah.
Save this.
Yeah.
This is popping up and I noticed it was like his.
Oh, that's a good point. Let me mention that to the class. Don't forget to save this as an XLM because right now it's just an XLSX file, right? So you need to make sure you save it as a macro enabled workbook instead of just an XLSX work.
That one. Just run it as a macro.
Yeah, you can go back to the Excel file itself. Yeah, right there. And then click on, instead of Excel workbook, click on macro enabled. There you go. And that'll save your code.
Okay, that's it.
Okay, good.
Thank you.
Yeah, yeah. I know, right? That's good stuff. On a scale of 1 to 5, did you guys, how much did you guys understand this one today? 1 to 5. 3s, 2s. Okay. 2.5. Great. That's probably about average. Question.
It's true. Mike?
Oh, interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9 is true. Does that follow all the rules? I mean, that might be valid ISBN. It could be valid, right? That might. Yeah, yeah. Because the math doesn't work out.
Okay, just put that.
Right, right. And that's, I mean, 1, 2, 3, 4, 5, 6, 7, 9 X. I would search that on Google. See, what is that really? That might be a valid ISBN.
So it has to be, so I can't just do, I can't do my numbers.
Correct. And that's the whole point. The whole point is to avoid random ISBN numbers. Just to get an accurate ISBN number. Now I'm really curious. Is that a valid ISBN number?
Something like that.
Oh, interesting. That's the name of the song. Do like an ISBN search or something. Type it. Let's see if that's a valid. Look at that. Yeah, ISBN 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 X. So that's like that's so funny. That's like so then if you do 5, 5 or 7, 7 or 6, 6, it's gonna be like
Okay, so
it's gonna be like no, that's not like that.
because we're using.
Yeah, because we're using that logic.
Okay.
Isn't that crazy? I mean, it's a little bit cool. It's a little bit crazy. Yeah, it's so cool. It's like, wait, what is going on? Right, right. Yeah, isn't that crazy? It's like the math behind. Yeah, yeah. It's the remainder. That's right. So we just followed along with the wiki. And the same thing works for credit cards, right? I mean, if you put in a credit card number, it's going to do the same thing. It's going to do some kind of math algorithm that checks to make sure, oh yeah, this is a valid, before it checks to see if there's any balance in the account or anything like that. It's going to check first, is this a valid number?
So it works.
That's it. That's it. I mean, if Wiki says it, it must be true. But do you have the Wiki site pulled up? Yeah. So it talks about that, right? So it talks about 10 check digit calculation. I mean, it's pretty open and say, okay, if you do all these calculations, it's going to be a valid ISP to result in a valid ISBN. So they only give out valid ISBN book numbers, right? So they don't do like the ones you were talking about, 5577, to prevent. I mean, now it's all about security. When they came up with this ISBN 10, I think that came out like in the 70s. Yeah. But pull up the project. Pull up the project 13. Yeah, calendar or assignments. Is it assignments? Can you see inside? Yeah. I think it's due next week, next Wednesday. Yeah. So load that, open it up. I'm just curious to see. I think it shows you the steps. I just want to make sure. Into branch. Right click, bring it down. Look at you. You know the process. Yeah, it's already a macro menu. It's nice. So I'm curious if you pull that up and then pull the assignment sheet out. Okay, so it gives you ISBN. And it should give you, yeah, so there's all the actual rules. Sum all the digits in even positions, multiply the result. Sum all the digits in odd positions. Sum the results of steps 2 and 3. That was kind of Spencer's question, which was, who came up with these rules? I mean, those are some crazy rules. In fact, I want to show the whole class this. Question? Else if x is less than 10, let's see, what's x? Oh, nice. Because it's going to be,
It's whatever we want to try.
yeah, 9 or less. And x is equal, so, oh, nice, nice. Love it. That works. That's beautiful. Love it. Can we just pull up the project just to give you a sense for what this looks like? So if I go to the site and I pull up on the assignments and I look at the project, ISBN validator, second project. Again, projects take some time, so it might be a good idea to start looking at this this weekend. Let's save it in my downloads, and then I will open the folder, right click, unblock. And when you go to this, it actually shows you the calculations that you need to make, just like we've done today with the ISBN 10. But the ISBN 13 has different rules. So I'll go to Atlas, I'll go to instruction sheet, and here's the rules. ISBN stands for International Standard Book Number. 2007, it was changed to use 13 digits. So here are the steps. There's 5 steps to get the check digit. The first step is sum all digits in even positions, multiply by 3. So here's the ISBN number, that 13 digit. Here's the 7 and the 2 and the 4 and the 1 and the 3 and the 5. Those are all in the even positions. So you add those up, then multiply all of that sum by 3. Okay, that's the first step. I mean, that's not too bad, is it? Grace, what's that exhale mean? Oh, okay. One way to do it is if you do a for loop, just like we did in our code before, what if you did a step 2? You know what I mean? If you had a step 2 in your for loop, oh, that's the other one. Instead of doing instead of just doing a for x 1 to 9, you could do a for x 1 to 9 step 2. You could do a step 2, and you could step, or it'd probably have to be even, right? It could be 1 to, or 2 to 13, something like that. And if you did a step 2, it would do every even number. Right? Something to that effect. There's a couple different ways to do it. This is just one idea off the top of my head. You could do the calculation inside the loop. You could go up by 1 inside the loop and just do a calculation to see if that digit is even or odd. A couple different ways to do it. That's the first step. Second step, sum all the odd digits and just sum them together. You're not multiplying by anything, just sum them up. Again, here's the 8, here's the 1, here's that 3 and the 5 and the 2 and the 4, right? You're summing all those up. Sum the results of step 2 and 3. You sum those together. Take the remainder. So this is mod 10, right? We're dividing by 10. What's the remainder? That's going to be 8. Or excuse me, what is it? Oh, 8 times 10 is 80, remainder 9. So the remainder is actually going to be 9. Subtract from 10 to get the check digit. 10 minus 9 is 1. If 1 is the last digit, then it should return true for an ISBN. Not bad. I mean, based off today's video, you might be able to do that in an hour and a half, 2 hours. With ChatGPT, 5 hours?
Yeah.
Might increase, might not decrease. But that's it. So that is pretty cool. So again, what we've done today is we have created a user-defined function. We can create the code for that, and we're passing code into the function. It's coming out as true or false. We can actually create another function to pass information into that function and pass that information back into our parent function here and continue this function here. Okay, I think that's it for today. Thanks, everybody. Let me know if you have any questions. Happy to stick around. We'll see you guys on Tuesday, not Monday, and Wednesday. Tuesday. Okay, good job. Question?